Hey, so this is going to be a little bit of a review and kind of like an introduction to momentum and impulse practice problems. So this is straight off your classwork worksheet. So if you want to follow along as I go, totally fine. I'm not going to go over all of them because I really want to see how you're doing at the end of it. But let's just go over a few. So I'm going to leave the first three to have you do on your own. Make sure that you're referencing back chapter 8. A lot of this stuff is kind of conceptual ideas. Like if you understand what kind of force and what that does to your velocity, then you should be okay with this kind of stuff. If you understand that force times time is going to increase your change in momentum, then you should be okay. And that if you're coming down with the same amount of momentum and you need to decrease it down to 0, what you want to do to your time in order so you don't feel as much force. So what I really want to do is start with number 4. So I've written number 4 on my little whiteboard here, and let's just get started. So a baseball pitcher claims he can throw the ball with as much momentum as... Okay, so let's just see what this is gonna look like. A baseball pitcher claims he can throw the ball with as much momentum as a speeding bullet. If the 0.03 kilogram bullet travels 500 meters per second, how much momentum will it have? That's the first part of the question. And then part B, how fast will the pitcher have to throw the 0.145 kilogram baseball to have as much momentum as the bullet? And does this seem possible? Okay, so for part A, you have to recognize what we're given in the problem. So remember, mass is measured in kilograms, velocity is measured in meters per second, and your momentum is measured in kilogram meters per second. So what I know now is that I am given the mass of the bullet. And the sub bullet is totally optional. It always helps me to really write out what I'm writing. So if this is also helpful to you, absolutely carry on and do it. And we're given that that mass is 0.03 kilograms. And we're also given that the bullet travels at 500 meters per second. So this is going to be the velocity of the bullet. And that is 500 meters per second. And to solve for the momentum of the bullet, all we have to use is our momentum equation that says P is equal to M times V. So we want to use the mass of the bullet times the velocity of the bullet. And you can go ahead and try that out now. And you should get 15 kilogram meters per second. Okay, so this is for part A. All right, and the baseball pitcher is claiming that he can throw as much momentum as the speeding bullet, so as much momentum. So what we want to do is we want to use this momentum that we're given in part A for part B, because we want those momentums to match, right? If he's claiming that he can match this momentum, then the momentums should match. And then we're just asked, okay, with this increase in mass, how fast does the pitcher have to throw the ball? So P of the bullet, or the momentum of the bullet, has to equal the momentum of the ball. All right, so it has to be equal to this 15 kilogram meters per second. But the mass of the ball is equal to 0.145 kilograms. Okay, so for our equation P equals mv, we need to solve for the velocity. All right, so we need to get v alone. So in order to do that, we just need to multiply out mass. So that's going to cancel the mass on this side, and we're going to be left with velocity is equal to your momentum divided by your mass. So the momentum, again, it's the exact same as it was for the bullet because we need these momentums to match. So it's going to be 15 kilogram meters per second, and we're going to divide that by the mass of the baseball. So go ahead, try that out. What is the velocity of the ball? All right, you should get that it's 103.45 meters per second. And to put this into kind of perspective that we understand, this is around like 220-ish miles per hour. So that's really extreme. So does this seem possible? Not really. All right, because again, pitchers tend to throw at like 100 miles per hour. Okay, so moving on to our next example, this is going to talk about impulse. And just to refresh your memory, impulse is equal to your force times time. All right, impulse is equal to force times time. So while pushing someone on a swing, Yvonne does an underdog and pushes with 30 newtons for 0.5 seconds. How much impulse does she apply to her friend? So again, force is measured in newtons, time is measured in seconds. So we are given a force and we are given a time. All right, so this is 30 newtons and the time 0.5 seconds. So what is the impulse? You just have to multiply those two together. So go ahead and try that out now. You should get 15 newton seconds. Okay, so now for part B. Yvonne then decides that she wants to be lazy. All right, so she no longer wants to do the silly little underdog thing. She just wants to sit down and push the kid on the swing and not even apply that much time to it. All right, so our new time is 0.1 seconds. Okay, so she's no longer doing the underdog thing, but she wants to match the impulse. She wants to match this impulse right here, as if she was doing it. But she only wants to apply it for that amount of time. How much force does she need in order to match this impulse? So we're trying to solve for F in this case. We're given T of 0.1 seconds, and we're given an impulse because it's the same amount of impulse that we need to match from the previous part, 15 newton seconds. Okay, so what we need to think about is how to solve for F using our impulse equation. So let's just write out this equation and solve for F, or get F alone. How do I get F alone? Well, I need to divide out by time. That's all I gotta do. Then I'm gonna cancel out my time here. I'm gonna be left with time on my other side. So force is going to be equal to my impulse divided by time. Okay, so again, my impulse is 15 newton seconds. My time is 0.1 seconds. So how much force is needed in order to match this impulse? And if you said 150 newtons, then you are absolutely correct. Well done. All right, so moving on to the next problem here. As the stoplight turns green, Aaron punches that gas in his 1,500 kilogram SUV. As the engine tries to turn the wheels, the ground exerts 7,000 newtons of force forward on his vehicle. If Joe keeps the gas pressed for 10 seconds, how fast is he moving at the end? So again, just to kind of refresh your memory, all right, the change in momentum, again, that delta P, is equal to impulse. So if we broke this down further by, saying, all right, what equals impulse and what equals our change in momentum, we can say that the change in, or I should say the M times the change in V is equal to F times T. Okay? And again, our change in V is that velocity final minus that initial. Right? So MV equals FT. So now using this information, let's find out what we're given in the problem and find out what we need to solve for. So Aaron punches the gas in his 1,500 kilogram SUV. So that is going to be the mass. The mass is 1,500 kilograms. And how did I recognize that? Well, mass is measured in kilograms, so I just kind of recognized, oh, that is the mass that I'm given. And remember that force is given in newtons and time is given in seconds. So as the engine tries to turn the wheels, the ground exerts 7,000 newtons of force onto the vehicle. So again, I'm given a force in this problem of 7,000 newtons. If Joe keeps the gas pressed for 10 seconds, so my time in this case is 10 seconds, we want to know how fast he's going to be moving at the end. So V is a question mark to us. All right, so we are trying to solve for how fast or v here. So using my equation right here, m equals delta v, m times delta v equals ft. How do I get delta v alone? All I have to do is divide out mass. All right, so it's going to cancel out mass on this side. I'm going to be left with mass on the other side. So delta v is equal to my force times time divided by my mass. All right, so delta v is equal to my force, 7,000 newtons, multiplied by the time that the force was being applied, 10 seconds, divided by the mass of my vehicle, or the mass of my object. All right, so your delta v should be equal to, take 7,000, multiply it by 10, divide it by 1,500. Your delta v should be equal to 46.66 meters per second. All right, so this is my delta v, and delta v stands for your final velocity minus your initial velocity. Well, Aaron was stopped, right? So his initial velocity is 0. So really all this saying is that this is your final velocity. Okay, so your final velocity for this car is 46.7 meters per second. Again, because this is 0, so all this is really saying that delta v is equal to vf. All right, and because I still have more time on the clock, I want you to try to do the rest of them on your own. I know that it can be kind of challenging, but feel free to draw pictures, use your notebook, all that good stuff. Let's just go over the equations that we know and yeah, use this time up. So momentum, unit equations. So this is basically just going over momentum and impulse. So momentum is equal to mass times velocity. Impulse is equal to your force times time. Our change in momentum is equal to your force times your time. So our change in momentum is equal to mass times our change in velocity equal to force times time. Okay, and that's all we really know so far. Okay, so if we wanted to just solve for the momentum at a particular point, we can use P equals mv. If we just wanted to solve for impulse, impulse equals ft. If we wanted to solve for the change in momentum, then we could use our impulse stuff. Or we could use, all right, what is our velocity initial? What is our velocity final? Is our mass changing at all? So yeah, this is kind of the big equation here. This is kind of the one that's kind of scary to people, but all it is saying is that your change in momentum is equal to your force times time. And just to kind of go over things one more time, mass, the units for that I'm just going to write in these little brackets. That's kilograms. Force, it's newtons. Time in seconds. And what else do I need? Velocity is meters per second. And in this section, if you ever see speed, it just is your velocity, right? Because speed is when direction doesn't really matter to us. So if direction doesn't matter to us, you might see it as speed. But yeah, use this stuff to recognize what you're given and what you need to solve for. And always write down what you're given. Write down the equation that you think you need to use. If you have to solve it out in a different way, make sure that you rearrange that equation and then plug in the stuff and do the math. All right, if you have any questions at all, send me an email. I'll be happy to get back to you and maybe even make another video on what you need to do for these practice problems. Try your best on this stuff. Try your best on the homework. We're going to go over this stuff tomorrow. All right, bye.